Day 239 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem. This time we're at day 239 and we're still going strong, y'all. Today we have question number 637, average of levels in binary tree. The difficulty level is easy, so you already know we're going to keep the solution as simple and easy to understand as well. So let's get into it. Question says, given the root of a binary tree, return the average value of the nodes on each level in the form of an array. Answers within 10 to the negative fifth power of the actual answer will be accepted. So let's look at example one so we can break that down and see what they mean. It's pretty self-explanatory though. So in example one, we have the input root equals a binary tree 3, 9, 20, 0, 0, 15, and 7, which is represented in this picture right here. The output is 3, 14, and 11. Explanation says the average value of nodes on level 0 is 3, on level 1 is 14 and a half, and on level 2 is 11. Hence, we return 3, 14, 3, 14 and a half, 11. Now let's look at this picture so we can figure out how we're going to do this. First thing we need to know is how we're going to traverse this. And in order to traverse this, we're going to do a breadth first search. We're going to do a level by level traversal, y'all. So that's what a breadth first search is. It's going level by level. And in order to solve this problem, that's what we need to do, because we want to find the average of each level, right? So the average of the first level, it would be 3. It's 3 by itself. So the average would be 3 because that's the only value that there is. Boom. So that's why the 3 goes right here in the output. Then 9, the average, then we're going to average this level, right? So 9 plus 20 equals 29. 29 divided by 2 is going to give us 14 and a half, which is right here. And that is the average of 9 and 20, because we add 9 plus 20, then we divide by 2 to find the average, because there are two values that we are trying to average. Then we need to find the average of 15 and 7, so we add 15 plus 7, that gives us 22. We divide that by 2 as well, because there's only two values to get the average, and that gives us 11. Thus, the average of each level is 3, starting with the 3. The second level average is 14.5, which is the average of 9 and 20. And then the third level average is 11, which is the average of 15 and 7. And that's what we need to do to solve this problem. Now let's look at example 2, where all they really did was switch the sides of the nodes. But as you can see, since we're doing a breadth first search and we're going level by level, it doesn't really matter what side or what subtree the values are on if the values are going to be the same. You see, all they did was take this 15 and 7 and make it the children node of 9 instead of 20, but the averages remain the same. So you can see that by saying 3, let's go through it. 3, average of 3 is just 3. Boom, same thing. 9 plus 20 divided is 29, divided by 2, going to give us 14.5 again. And then 15 plus 7 going to give us 22. We divide that by 2, that's going to give us 11 again. So it's the same output. All they did was switch the subtrees or the children nodes, but since we're doing it by level traversal anyway, a breadth first search traversal anyway, it doesn't really matter which subtree these children nodes are coming from. So now that we understand the question, let's get into the solution, the actual fun part. But before we get into the solution, y'all, if you need any new Apple AirPods, go ahead and check that link out in the description. Then after you do that, don't forget to like, comment, and subscribe, y'all. So let's get into it, y'all. So the first thing we need to do is we need to check to see that there is a binary tree or a tree actually exists, right? So in order to do that, we got to make sure that the root exists. So in order to do that, we can do that using a guard statement by saying guard let root equal root, else we could just open up the brackets and return a blank array, because that means no tree exists if the root is nil. And remember, we have to return the average values of each of the nodes on each level in the form of an array. That's why we're going to return a blank array if the root is nil. So now what we have to do is we need an array that's going to store the average values, right? So we could just declare a variable and we could call that result, set that equal to an array, open up the square brackets of doubles, because there might be a double is just when we have decimals. So there might be decimals in our answers. So it will be an array of doubles. We can initialize it with the parentheses at the end like so. And once again, this is going to store the average values of each level. Now we need a queue to facilitate the level order traversal, right? So we need a queue for the breadth first search. First thing, in order to do that, we're just going to declare a variable. We could call it queue, and we could set that equal to a tree node, or excuse me, an array of tree nodes like this, or a binary tree. Boom, just like this. Boom. Now we need to start by adding the root of the node to the queue, right? Because the root is always going to be, the average of the root is always going to be the value of the root, because there's only going to be one root. So we could just do that. We could just append the root to the queue just immediately by saying queue.append, open up the parentheses, root, just like so. Now it's time to get into the fun part, the while loop, right? So this is how we're going to process each level of the tree. So we're going to say while exclamation point queue is not empty, right? Or excuse me, we're going to say is empty, but this exclamation point means it's not empty. So while queue, or excuse me, while exclamation point queue is empty, which means while queue is not empty, we are going to declare a variable called sum, and we'll set that equal to 0.0. And this is going to store the total value of the nodes at whichever current level we're on. So the current level, we're just going to store the total value of that level in sum. Now we need to declare a variable. We could call that count, and this is going to let us know or keep count of the number of nodes on the current level. So we'll say let count equal q dot count. So once again, that's going to keep the number of nodes on the current level that we're on, right? So that's going to give us the number of nodes that we're working with, because that's what we're going to have to divide by later on. So now we can say for underscore n 0 up to count, open up the brackets. We need to say let node equal q, excuse me, dot remove first, just like that. And that's just going to remove the first node from the queue for processing. Now we need to add the value of the current node to sum. So in order to do that, we're just going to say sum plus equals double, open up the parentheses, node dot val. Now we need to see if the current node has a left child and add it to the queue. So in order to do that, we are just going to say if let node node equals node dot left, boom, open up the brackets. Then we're going to say q dot append. We're going to append it to the queue by saying q dot append left node. Now we need to do the same thing for the right node. So if the current node has a right child, we need to add that to the queue as well. So we could do that by saying if let right node equals node dot right, open up the brackets. We're going to say q dot append, open up the parentheses, right node, just like so. Now we need to compute the average for the current level and add it to the result array, right? So in order to do that, we're going to come right here outside of the for loop, and we're going to say result dot append, open up the parentheses. We're going to say sum divided by, this would be a double, So double, open up the parentheses, count. Now remember, the sum stores the total value of the current level, right? Which we need for when we're finding the average. So the sum is going to find the current value. In this example, say 9 and 20. Sum's going to find the current value of 9 plus 20. Then we're going to divide it by count. And count is going to be a double just in case it's because we're going to need decimals. So count, remember, count is the number that stores the number of nodes on each level, right? So count is how we count how many nodes are on this level. So we're going to do sum 9 plus 20 is going to give us 29 divided by the count. There's only 2 nodes on this level, so we're going to divide 29 by 2, and that'll give us our 14.5 that we're looking for this level, right? So then after we do that, now we still have to, or all we have to do really is we just have to return the result, because this is where we append the averages to the result, and then we have to return the result in the end. So now let's run it. Make sure that runs properly. Let's see. And look at that, it's accepted. So let's submit it, make sure it stays accepted. Let's see. Okay, look at that. 3 milliseconds beats 41.07% of users with Swift, y'all. Not too bad. We're going to get those numbers up later as we go further down our LeetCode journey. Right now, we just are focused on being able to solve the problem and being able to come up with a solution for each problem. I feel like this is a good and easy to understand solution that we will be able to incorporate what we learned from this problem into further problems, because we'll be able to understand this problem a little easier, right? We're not trying to make the problem so hard that we can't understand it, because if we can't understand it, we won't be able to apply that knowledge later. So I feel like this is a good solution for people no matter what level of your programming journey you're on. So make sure you get one more look at the code, y'all, before we leave. Get one more look at it. I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.